Imagine, just for a second, a universe that's entirely bound by a hidden code, a structural blueprint so incredibly fundamental that everything we see and know is just a shadow of its true form. What if we could actually decipher that code? Well, today we're exploring a mathematical framework that is trying to do exactly that. Welcome to This Explainer. Lately, I've been diving into something absolutely fascinating, Logos field theory, and specifically how it fits into the grand architecture of the Adelic Langlands program. We're talking about some of the most profound mathematics out there right now. So let's walk through these visual blueprints together and try to break down the equations that make it all tick. Here is our roadmap for the journey. 1. The grand mathematical architecture. 2. Bridging geometry and arithmetic. 3. Filtering the mathematical noise. 4. Smoothing the local singularities. And finally, 5. The perfect global balance. All right, let's jump right into part 1, the grand mathematical architecture. Take a look at this foundational equation. This is our master blueprint. Over on the left, L squared of G defines what we call our global Logos state space. Essentially, these are our square integratable automorphic forms. But the real magic? That happens as we move to the right. We take that continuous global space over the Adelic ring of Q, and then J-theory maps it directly into a sum of global irreducible representations. We are quite literally taking rigid arithmetic and weaving it together with continuous geometry into one unified Adelic architecture. It's a massive undertaking. To actually navigate an architecture this huge, mathematicians break the process down into 3 distinct tiers. First, at the micro level, we use spectral projection to extract pure, isolated data at individual prime numbers. Then comes the bridge, J-theory, which binds those isolated fields into a continuous ring. And finally, zooming all the way out to the macro level, Logos field theory establishes our global reciprocity. That brings us to part 2, bridging geometry and arithmetic. So the core challenge we're facing lies right here in this duality. The automorphic or spectral side behaves a lot like a continuous ocean of waveforms, flowing, connected. On the flip side, the Galois or arithmetic side is more like rigid, isolated islands of discrete prime numbers. The big question is, how in the world do we mathematically map a continuous ocean to a bunch of discrete islands? The answer is a concept called strong multiplicity 1. You can see the mathematical lock right here at the bottom. What this does is force the automorphic spectral identity, our continuous ocean, to perfectly match the Galois arithmetic identity, which is the Chebotarean density of those discrete islands. It creates an unbreakable tether, proving that the highly localized physical signatures perfectly match the global arithmetic invariance. Moving on to part 3, filtering the mathematical noise. Now, when we zoom into the micro level and actually encounter ramified primes, things get messy. Local symmetry breaks down. To fix it, we have to bring in a Weil-Deligne representation. Check out the scale balancing factor on the right, p to the -1 times n. Because our local symmetry gets disrupted by the nilpotent monodromy operator n, which captures geometric defects, this specific factor acts as the crucial glue. It forces the continuous dynamics to tightly, cleanly interlock with the discrete p-adic geometry of the prime. To handle all that underlying chaos, we apply spectral projection. By mathematically slicing the data, we can isolate the tame defect on the left and neatly sum up the wild higher harmonics on the right. By computing the trace, we extract a very precise, exact integer that dictates the power entering the global Euler factor. It's absolutely brilliant. It mathematically reduces all that wild static down to a perfect, single tone, totally stabilizing the local environment. This perfectly sets up part 4. Smoothing the local singularities. Okay, so the noise is isolated, right? But now we're staring down incredibly dense, wildly different matrices at the local level. How on earth do we force these completely divergent mathematical paths to align so we can actually build out our global structure? We pull it off using non-commutative parahoric boundaries. We start with a left path and a right path, which give us 2 vastly different complex matrices. But when we evaluate them inside the Steinberg subquotient, just look at the conclusion at the bottom. Phi times n equals p to the -1 times n times phi. Those 2 completely divergent paths elegantly collapse into a single, identical conclusion. It's almost like magic, but it's just pure math. Just to be clear, when we say singularity in this context, we aren't talking about a black hole in space. Think of it more as a rough, chaotic spike sticking out of our mathematical landscape. If we want to build a continuous, flawless global theory, that spike has to be perfectly sanded down. To smooth out that spike, we apply a filter constraint. The deforming paraphoric matrix flow starts out full of messy, complex crosstalk. But as it gets funneled through the Jacquet functor, that complicated unipotent subspace is completely stripped away. What drops out into the decoupled torus space is beautifully clean and diagonal, which perfectly stabilizes the analytic behavior of the field. You can actually see this entire smoothing process visually across the system through the Taylor-Wiles inverse limit. Notice how the singular input at the top starts out jagged and chaotic, but as n approaches infinity, we literally average out those local spikes. By modding out the regularization, we're left with what we call the sliced truth at the bottom, a perfectly flat, stable global geometric identity. And that leads us to our final stop, part 5, the perfect global balance. This brings us to the grand climax of the entire architecture, the global functional equation. Look at how beautifully symmetrical this is. The integral on the left for lambda of s, pi perfectly, mirrors the right side. All of those highly local, chaotic pieces, all those singularities we just painstakingly filtered and smoothed, they all culminate right here. They perfectly balance each other on a cosmic mathematical scale, creating an equation that defines the arithmetic architecture of the universe itself. Just to recap, this balanced equation really rests on 3 foundational pillars we've been tracking. First, you have the epsilon factor, which acts as the exact global root number. Second, the negative sign, which is derived straight from the exact local Hockey eigenvalue we isolated earlier. And third, the exponent, representing the exact Artin conductor we extracted when we sliced away the mathematical noise. Every single piece plays a vital, irreplaceable role. So after looking at all of this, it leaves me with one massive thought. If this intricate mathematical architecture can actually perfectly filter, smooth out, and balance the inherently chaotic primes of the universe, what other profound universal truths might be hidden inside the Adelic Langlands program, just waiting to be discovered? It really makes you wonder. Thank you so much for joining me on this explainer. Keep questioning the code of the universe, and I'll catch you next time.